Okay, so we've talked a lot about slope in this little season here, but what we really want to focus on now is not just the slope of the tangent, but the slope of the normal. So what's the slope of the normal? Well, we know from linear algebra experience that a tangent is obviously to the curve at some given point, whereas the normal is actually going to be at 90 degrees to the tangent. That's what the normal means. It simply means it's at right angles to the tangent. And we know from linear algebra that there's a certain equation we can use. Let's say that the slope of this line is m subscript 1. Well, if we wanted to find m subscript 2, the slope of that line, then m subscript 2 would actually be equal to negative 1 on m1. It would actually be the negative reciprocal. And you've probably studied that a bit before when you've actually looked at how this works. You know that if the function is going in this direction, it's obviously going to be positive, whereas if it's heading in the other direction, it's of course going to be negative. That explains the negative part, and obviously it's just going to be reciprocated as well because of the nature of the angle. So we're not going to focus too much on the linear algebra side behind this phenomenon. We're actually going to focus on how we can use derivatives with this, because of course, at the end of the day, that's what this whole season's about. Okay, so let's say we have a function f of x, and we can use the sum rule to differentiate it. The f of x is a cubic function. It's equal to x to the 3 plus 6x squared plus 5x plus 3. So you know, it's got quite a few terms there. We have 4 terms that we need to differentiate. Because it's a sum rule, it just means we can differentiate each term individually. And that's really good. It means we don't have to worry about quotient rule or product rule, like we had in our other videos. Of course, those rules are still handy, because sometimes we can get functions like that, and still need to find the slope of the normal at a given point. Okay, so first off I'm going to differentiate this, and then I'm going to define a point at which I want the slope of the normal to be. Okay, so let's have a go. So the f prime of x is the derivative. It represents the slope of that original function. And in this case, we can denote that as being 3x squared for the first term. Again, we bring the actual exponent out the front, it becomes our coefficient, and then we actually subtract 1 from our power, so it's 3x squared there. We then do the same here, we multiply the exponent by the coefficient, so we get 12. 6 times 2 is 12. And then we subtract 1 from the exponent, so we get 12x. And now we have x to the 1 here, so we move that 1 down, and it's 5 times 1, which is of course 5. And then it's x to the 0, and anything raised to the power of 0 is 1. And then we're done because the derivative of a constant is 0, like I showed you earlier in the season as well. So there we go, we have differentiated using the sum rule. But now it's time to find the slope of the normal at a given point. So let's say we wanted to find the slope of the normal when x is equal to 2. Well, what we want to do there is we actually want to find the slope of the tangent and then use that inverse reciprocal concept. So we differentiate it using that power rule that we looked at previously, but what we want to do now is actually go, well, okay, what's the f prime of 2? And in order to do it, it's just a simple matter of substitution. Wherever there's an x, it is now a 2. So we have 3 lots of 2 squared, plus 12 lots of 2, plus 5. Let's go through this. So that's the same as having 3 times 4, which is 12, plus 24, because 12 times 2 is 24, plus 5. And then we can see that 12 plus 24, we know our 12 times tables, so it's going to be 36, plus 5, which is going to be equal to 41. And that is the slope of the tangent. But we want the slope of the normal, not the slope of the tangent. Again, we know that therefore the slope of the normal is going to be equal to negative 1 on 41. Again, it's just a negative reciprocal concept. What happens is we have a -1 divided by our slope of the tangent, which is 41, and then of course it's negative because it's heading down in the opposite direction. That's the actual equation there. So we get -1 over 41. Again, in case you're having a hard time conceptually understanding this, again, we've looked at the function, we've looked at a certain point, we've got a tangent, which is a straight line that represents the slope at that given point, and we just found the slope of a line that cuts through the same point, but at 90 degrees, by using that negative reciprocal concept from algebra that you probably would have studied before. So from that we found the slope of the normal. And what we can actually say now is that, well, if we had the actual coordinates, so we know that x equals 2, so if we actually substituted 2 back into our original equation, not the differentiated one, but just to work out the coordinates on the original curve, then we would go 2 to the 3 plus 6 to the 2 there. We'd put in all the 2's where they're originally x's, so it becomes 8 plus 24 plus 10 plus 3. And of course, it's going to be 24 plus 13, so it's going to be 37 plus 8. And that's of course going to be 45. So we got the coordinate point 2, 45 on the original function. And from that we can say, well, okay, let's write this as a linear equation, because the slope of the normal is actually an actual linear equation, because the slope of a tangent was a linear equation. It's a line that just cuts the curves. So we can go, well, okay, well, now that we have these points, y take the value we have for the y coordinate, which of course is 45, over x take the value of the x coordinate, which is 2, equals the slope of -1 on 41. And that's how we'd actually write it as a linear equation. And what you can do, if you wanted to, is you could rearrange that such that it's in y equals mx plus c form. I'll let you do that as an extension to this episode if you're interested. But what you do is you just use your general algebra rules that you've come across before. You'd move that x take 2 up to the other side and it would be in the numerator. You'd expand that and then you take the -45 over to the other side. And that's how you get it into linear form. And then you've got the equation of the normal. And you've actually worked out that line at 90 degrees, its properties, what it actually is on the Cartesian plane. And that, my friends, is looking at the slope of the normal, the slope of the tangent, and tying together a few loose ends in our differential calculus course. So hopefully you got the sum rule here. You understand that the process is simply just differentiate it. Substitute in for the point you want the slope of the tangent for. Use a negative reciprocal to get the slope of the normal. Then plug in the value into your original equation, not your derivative, in order to actually work out the point. And then rearrange, because again that point is where the normal cuts through, so it's important to the actual linear equation. But I then rearrange to get y equals mx plus c form. Thank you very much for watching, and in the next video we'll be moving on to some more exciting stuff. We've covered all our rules, so we've got a few new concepts coming up.